For this experiment, we require sodium oxalate for the standardization of KMnO4 solution, 0.1 normal ferrous alum solution for the estimation of persulphate ion, 0.1 normal KMnO4 solution for the estimation of ferrous alum solution, phosphoric acid, 5 normal of H2SO4. There are 3 parts in this experiment. The first part is standardization of KMnO4. Second part is back titration. Third part is blank titration. Let's first do the standardization of KMnO4 solution by preparing 0.1 normal sodium oxalate solution. To prepare sodium oxalate solution, weigh 0.67 sodium oxalate. Transfer this quantity into 100 ml beaker and dissolve minimum quantity of water. During the dissolution, measure 10 ml of 2 normal H2SO4, add into the clear solution. Transfer the clear solution into 100 ml of standard measuring flask. Give washing to the beaker and use that washing solution for the dilution of solution. Dilute the solution up to the mark by using distilled water. Rinse and fill the burette with 0.1 normal KMnO4 solution. Adjust the zero level. Now transfer the 0.1 normal sodium oxalate into 100 ml beaker and pipette out 10 cm³ of it into 250 ml conical flask. Now measure 2 normal H2SO4 25 ml and add it into the same flask. Heat the flask to heat the content of the flask up to 40 to 50 degrees Celsius. Titrate the content of the flask under hot condition with 0.1 normal KMnO4 solution till the end point colorless to faint pink. The burette reading is 10 ml. Take 2 more readings to get constant burette reading. For the standardization part, the titrant is given KMnO4 solution. The titrant, that is solution in a conical flask, is 10 cm³ 0.1 normal sodium oxalate, to which 25 cm³ of 2 normal H2SO4 is added. The indicator, as KMnO4 is pink colored, it acts as self indicator and endpoint is colorless to faint pink. The constant burette reading after 2 reading is 10 cm³. Thus 10 cm³ of 0.1 normal sodium oxalate solution require 10 cm³ of KMnO4 solution. Hence, normality of KMnO4 solution after calculation is found to be 0.1 normal. Now let's do the estimation part, that is estimation of persulphate ion solution. You are provided with unknown sample solution of persulphate ion in 100 ml standard measuring flask. Dilute the flask up to the mark by using distilled water. After complete dilution, shake the flask. Transfer the diluted solution into the beaker and pipette out 10 ml of it into 250 ml conical flask. Measure 3 ml of phosphoric acid. Add the same into the conical flask. Measure 5 ml of 5 normal H2SO4. Now to the same flask, add 0.1 normal of ferrous alum solution with the help of burette. Do the addition of ferrous alum solution drop by drop. After complete addition of 25 ml of 0.1 normal ferrous alum solution, keep the flask for 5 minutes undisturbed to allow the reaction between persulphate ion and ferrous alum solution. After 5 minutes, titrate the content of the flask with 0.1 normal standardized KMnO4 solution till the endpoint becomes colorless to faint pink. The reading is 18.4 centimeter cube. Note down the burette reading in observation table and take 2 more readings to get constant burette reading. The second reading is also observed to be 18.4. Thus, constant burette reading for this part is observed to be 18.4 centimeter cube. Thus, for the estimation of persulphate ion, that is for back titration, the burette solution is standardized KMnO4 solution. In the conical flask, we have pipetted out 10 centimeter cube of diluted solution. To the same solution we have added the acid mixture, that is 3 centimeter cube of phosphoric acid, 5 centimeter cube of 5 normal sulfuric acid, and we have done the dropwise addition of 25 centimeter cube of 0.1 normal ferrous alum solution. And we have titrated this reaction mixture against standardized KMnO4 solution till the endpoint is colorless to faint pink. Now let's perform the third part, in which we are going to determine how much quantity of ferrous alum we are adding into the solution. In the part third, the burette solution is same, but the solution in the conical flask, that is titrant, is a 10 centimeter cube of distilled water instead of 10 centimeter cube of sample. To the 10 centimeter cube of distilled water, we are adding the same reagents that we have added in the part 2, that is 3 centimeter cube of phosphoric acid, 5 centimeter cube of 5 normal H2SO4 and 25 centimeter cube of 0.1 normal ferrous alum solution. So in this way, the content of the flask prepared is titrated against standardized KMnO4 solution till the end point is colorless to faint pink. Note down the burette reading, that is 22.7, and take 2 more readings to get constant burette reading. Here the constant burette reading is observed to be 22.7 centimeter cube. Now do the calculations. Thus, the amount of ferrous alum solution added into the persulphate ion sample solution in terms of KMnO4 is 22.7 centimeter cube, that is CBR of blank titration. The amount of ferrous alum solution unreacted after the reaction gets completed is 18.4 centimeter cube, that is CBR of back titration, and hence amount of 0.1 normal ferrous alum solution used, that is reacted with 10 centimeter cube of diluted persulphate ion solution, is C equal to Z minus Y, that is 4.3 centimeter cube, and therefore 100 centimeter cube of diluted persulphate ion solution will require 10 into C, that is 43 centimeter cube. From the equation, that is stoichiometrically, 1000 centimeter cube of 1 normal ferrous alum is equal to 135 gram of potassium persulphate, which is equal to 96 gram of persulphate ion, and therefore 10 C centimeter cube of 0.1 normal ferrous alum solution equal to 0.4128 gram of persulphate ion. Let's calculate percentage error. The observed value of persulphate ion in the given solution is 0.4128 gram and expected amount is 0.42 gram, and therefore percentage error for this sample solution is observed to be minus 1.714%. Thus, results obtained are: normality of KMnO4 solution is 0.1 normal, 10 centimeter cube of persulphate ion solution require 4.3 centimeter cube of KMnO4 solution having 0.1 normal concentration. Amount of persulphate ion in the given solution is 0.4128 gram, and the percentage error observed to be minus 1.714%.